Hi, everyone. I posted the answer key for this worksheet, but I just wanted to quickly talk through a couple of them. They're kind of repetitive. So I'll talk through this first one first because this one's pretty basic. So this is a graph. This is your velocity function. So when it asks for velocity, the velocity is constant in this one, so it's always 10 meters per second. So this is 10 meters per second. Displacement is position, and so displacement, so the first derivative of position equals velocity. So if I'm given velocity and I'm asked displacement, I'm going backwards. So that would be the antiderivative, or you can say position or displacement equals the integral of velocity. So area under the curve. Displacement or position is area under the curve. So the area under the curve between 2 and 4, well, it's just a rectangle. Length, height is 10 and length is 2, so that's 20. Is it accelerating? No, because the velocity is constant, or the slope of this line is 0, so it's constant. Is it moving forward? Yes. Whenever velocity is positive, it's moving, and it's moving forward or to the right. So in this one, same thing. The velocity between 2 and 4 seconds, well, I'm just going to say, according to this graph, it's approximately 30. The displacement between 2 and 4 seconds is going to be this area. So that's a trapezoid. So I'm going to take this height, 20, this height, 40, take the average of it, divide it by 2, and the width here is 2. So the displacement is 60 meters. Check your units on that. I'm going backwards from velocity, so displacement is just a single unit and it's meters. Is it accelerating? Yes, it's accelerating because the slope of this line is positive, or the derivative is positive, and it's moving forward because the velocity is positive. So same kind of deal here. I'm going to go down here. What is the displacement between 2 and 4 seconds? That's just this rectangle, the area of this rectangle. Between 4 and 6 seconds is the area of this trapezoid, between 4 and 6. So that's where that came from. Again, it's accelerating after time equals 4, and it is moving forward. I'm just going to talk about one of these graphs quickly. So this graph, velocity is positive, so it's moving forward, but the slope of this line is negative, so acceleration is negative, so it's deaccelerating. Here, velocity is 0, so it's stopped. Here, velocity is negative, so it's moving backwards. The slope of this line is also negative, so acceleration is negative. So this is a situation where it's speeding up in the negative direction because both velocity and acceleration have the same sign. So this one, it's moving forward everywhere because velocity is positive everywhere. Here it has a constant velocity. Here it's deaccelerating, or the slope of this line is negative, and then it's constant again. So just kind of a quick summary there. A lot of the same on the back, but this first problem's a little bit messed up, first of all, because I can't do anything between 4 and 6 seconds because my graph doesn't go to 6 seconds. But I want to do this one. So average value, that's one of the chapter 5 formulas, is 1 over b minus a times the integral from 2 to 4. So the integral from 2 to 4 is going to be this area under the curve. We don't have the function, so this is definitely going to be an approximate. I'm just using these y values as an approximate. So this is my 1 over b minus a. These are the two heights. I just called this 1.8 and I called this 6. I want to take the average of those and multiply it by the width here, which is 2. So it's approximately 3.9. So it's definitely an approximation because this is a curve. Okay, the rest of these are kind of the same as what is on the front.